All right, this is our first video on solving systems of equations using elimination. Okay, to refresh our minds, let's look back and talk about some of the other ways that we've said we can solve a systems of equations. Think back to your last two units, your last two packets we've done. Okay, the first one might be a hint from this picture right here. Yeah. One way you can solve the systems of equations is by graphing. Right? You had two lines, you could graph them. And when you're looking at systems of equations, you're trying to find your solution to the system, which was what? Does this picture give you a little bit of a reminder? Okay, your solution is the point where they intersect. It's the point that's shared by all of the lines in your system. Okay, so we said you could do it by graphing, or you could do it by, what was our last unit on? Substitution. Right, we could manipulate our equations. Okay, so this last packet is on our third way to solve the system, which is elimination. This is our third and final way. Okay, so when you have elimination, there are 4 steps that you follow. The first step is to align your variables. Okay, if you look over here, I have 2 equations written in, remember this, ax plus by equals c? Good, they're in standard form. And I've lined up my x's, my y's, and my numbers. Okay, they all match up. After you've aligned your variables, you eliminate a variable. Okay, we can do this through addition or through subtraction. And we'll give some examples of those in just a little bit. But you're working to eliminate a variable or to get rid of a variable. Okay? Once you know one variable, your third step is to plug it back in and solve for your second variable. Right? If it's a point, you're looking for both an x and a y, because your solution is always an ordered pair. Okay, finally, you should always be plugging your answers back in to check them. Okay, you should plug your x's and y's back into your original equation to check and see if you got the correct answer. Okay, so let's try one. Here I have the equation negative x plus y equals 7 and x plus y equals 1. Okay, with elimination, you are looking to get rid of a variable, and the easiest way to do this is through opposites. Okay, think for a second. What if I had the numbers 2 plus negative 2? What's it going to equal? 0, right? What about 7 and negative 7? If I added them together, they're going to equal 0. Okay, what about 356 and negative 356? It equals 0, okay? This concept is what they use for elimination, this concept of opposites that equal out to 0. Okay, in my equation here, I have x's and y's. Do I have opposites in there? Okay, I see that I have a negative x and a positive x right here, a negative x and a positive x. Okay, if I set this up as an addition problem, I could say that negative x plus x, that's going to cancel out. This is going to equal 0. Okay? For elimination, you're going to compare all of your columns, all of your variables. So I've done my x's. Let's look at my y's. Y plus y is going to equal 2y. And 7 plus 1 equals 8. Okay? Since I had 0 x's, we're going to remove that from our equation, right? Because 0 times any number will just be 0. So my new equation is 2y equals 8. Okay, if I solve for y, I need to divide by my coefficient, and I get that y equals 4. Okay, we've eliminated and solved for our first variable. Now that I know what y equals, I can plug it back into one of my first equations. Okay? We can either plug it into negative x plus y equals 7 or into x plus y equals 1. Okay, let's plug it into the second one. That looks easy. So I'm going to have x plus 4 equals 1. If I subtract 4 from both sides, I get that x equals negative 3. Okay, negative 3 for x and 4 for y. Okay, if I wrote my answer as an ordered pair, in parentheses, I would say negative 3, comma 4. Now our last step said you should always check your answer. Well, since we solved using this one, let's check our answer in the first equation. Okay, negative x, well my x was negative 3, so negative x plus y, we had a y of 4, is supposed to equal 7. Okay, if I have a negative and a negative, this becomes positive. 3 plus 4, does it equal 7? All right, then we got our correct answer. We went back and we checked our work. Okay, let's try another one. Do you see opposites? Right, if we're using addition, we are looking for opposites. We're looking for a positive and a negative of the same number on one of our variables. Good, I see opposites here at our x's. I see negative 4x and positive 4x. So I'm going to set up my addition problem. Okay, 4x plus negative 4x, those are going to cancel. Okay, we've eliminated our x's. What is 5y plus 6y? Good, 11y. And 17 plus negative 6 is going to equal 11. Okay? If we divide by our coefficient, we get a y equaling 1. Okay, we have found our first variable. Let's plug it back in to solve for our x. Okay, this time we'll plug it into our first equation. We'll try something different. So I'm going to have our first equation here. Negative 4x plus 5 times, what's our y? 1 equals 17. Okay, negative 4x plus 5 equals 17. Remember, we do the opposite to get something to the other side of our equation. So we get negative 4x equals 17 minus 5, which is 12. And our x is going to equal 3. Okay, we got the answer 3, comma 1. Should we plug it back in to check? Of course, let's use the equation that we didn't use the second time, so we'll use this one. Okay, 4 times our x of 3 plus 6 times our y of 1 is supposed to equal negative 6. Correct? 4 times x plus 6 times y equals negative 6. Okay, let's see what we got here. 4 times 3 is 12, and 6 times 1 is 6. Does that equal negative 6? Uh-oh, I think we made an error. Look back over here. 12 divided by negative 4 should be negative 3. Okay, it's always good to go back and check your answers because you can find mistakes like this. So really, when I plug back in, I should have plugged in negative 3. Okay, let's try it again. 4 times negative 3 is negative 12 plus 6. And negative 12 plus 6 is negative 6. Okay, we got it right this time. All right, our very last one. Let's go. How do we do it? Good, we're going to set up an addition problem. Do you see opposites? Our negative 2y and our positive 2y. Right there is our opposites. Okay, our addition problem. 5x plus 3x is 8x. Negative 2y plus 2y gets eliminated. And 24 plus 24 is 48. Okay, 8 times what equals 48? Good, 6. So our x equals 6. Okay, let's plug it back in. We'll do our first equation this time. 5 times our x of 6 minus 2y equals 24. Okay, 5 times 6 is 30 minus 2y equals 24. You subtract 30 from both sides of your equation, and you're left with negative 2y equals negative 6. Okay, if you divide by negative 2 on both sides, you get y equals 3. Okay, so our solution is the point 6, comma 3 on our coordinate plane. Okay, should we check it quick? 3 times 6 plus 2 times 3 equals 24 using our second equation up here. 3 times 6 is 18, plus 2 times 3 is 6. 18 plus 6 equals 24. Yes. Okay, we have it correct. All right, sometimes you will not see opposites when you get your equations. Okay, you will see things that are similar but not quite opposite. Okay, in this case, I see negative 3y and negative 3y. Okay, my coefficient is the same number. To eliminate, we need opposites, right? So we're going to have to use subtraction. Okay, you always use subtraction when you have the same coefficient. Okay, you're going to have a positive and a positive. You're going to have a negative and a negative. Okay, I would write that down somewhere in your notes. That's a really important concept to remember. Okay, so since we have the same coefficients here, we're going to use subtraction. You're subtracting this entire second equation. Okay, so it might be a little hard to think about, but you need to make sure your subtraction goes to all parts of the equation. Okay, so I can think about this as 9x minus 7x. 9x minus 7x is 2x, right? I could think of this part, which might look a little confusing, as negative 3y minus negative 3y. Okay, if you subtract the negative, it's like adding, right? I actually have negative 3y plus 3y, and that's going to cancel. It'll be eliminated. Okay, and I have 24 minus 20, which equals 4. Okay, 2 times what equals 4? Good. X should equal 2. Okay, once I know my x, we can plug it in for our y. Let's use the second equation this time. Okay, 7 times 2 minus 3y equals 20. 7 times 2 is 14. Minus 3y equals 20. Okay, to get our 14 to the other side of the equal sign, we're going to subtract 14 from both sides. And you get negative 3y equals 6. Okay, when we divide by negative 3, we get that y equals negative 2. The solution to our problem here is 2 comma negative 2. You can always plug that back in to check it. Okay, let's try another one. This one says we're using subtraction, so I think that we should see two numbers that are the same. Okay, I see a positive 3y and a positive 3y. So we know instead of adding these equations, we're going to subtract them. Okay, what is negative 2x minus x? Good, negative 3x. What is positive 3y minus positive 3y? Good, that's going to cancel to be 0. And negative 9 minus 3 is negative 12. Okay, if we divide by our coefficient of x, we get that x equals 4. Okay, let's plug into our second equation this time to find our y. We have 4 plus 3y equals 3, right? Okay, if we subtract 4 from both sides, we get that 3y equals negative 1. And if we divide by our coefficient, we get that y equals negative 1/3. Okay, so our final answer, our ordered pair, is our x comma y, 4 comma negative 1/3. Okay, last problem. Let's try it quickly. This is another subtraction problem. means that there must be two numbers that are exactly the same. I see negative 2x and negative 2x here. Okay, so let's think about this as subtraction. What is negative 2x minus negative 2x? But those are going to get eliminated. Okay, what is 3y minus 6y? Got negative 3y. And don't forget that you're also subtracting over here, okay? What's 25 minus 58? Good, negative 33. Okay, if we divide by our coefficient, we get that y equals 11. Okay, let's pick an equation to plug that back into. Sure, let's use the first one. Okay, if we use this equation, we have negative 2x plus 3 times 11 equals 25. Okay, what is 3 times 11? Good, 33. Okay, and if we have positive 33, we're going to subtract it from both sides. And we have negative 2x equals negative 8. Okay, you divide by your coefficient of x, you should get that x equals 4. Okay, so just a reminder, when you're working here, and you go on to checklist 2, you're trying to decipher whether I'm going to use addition or subtraction. Okay, you're always looking for variables with the same coefficient. But in addition, you're going to have a positive and a negative. So you're looking for something like 2x and a negative 2x, or 12y and a negative 12y. Okay, you'll know that you'll have to use subtraction when you have things that are the same. So a positive and a positive, or a negative and a negative. Okay, so something like a 2x and a 2x, or a negative 7y and a negative 7y. Okay, you're always looking to see if you can find a pattern. Can you find it where you have the same coefficient? Can you find it where you have opposite coefficients? That will help you decide whether you're going to use addition or subtraction on checklist number 2, your practice problems.